I want to welcome everyone to the first webinar about applied sciences and technology in archaeology with an international scope, in which we are connecting Mexican, Israeli, and international researchers to speak about the sciences that helps archaeology to be what it is right now, to have a very objective field right now to understand past. As you know, as many of you know, this webinar will be recorded. We will send you the link that will be posted in our TAO YouTube channel. We will email it to you. And we have I want to thank two of the ambassadors from Mexico, Mauricio Escanero and Ambassador Vital from Israel in Mexico, who are joining us. And with this, I would like to, well, the goal of mixing Mexico and Israel is to strengthen the academic ties. And the best way to do it is to have the representatives, the diplomatic representatives and the academic representatives and the researchers who are joining us. So Ambassador Mauricio Escanero, if you can share brief words to us, it would be amazing. Thank you.
Thank you so much. It's a pleasure to be with you indeed. Thank you. You're listening to me?
Yes.
Yes. Yes. So thank you to all the webinar. My dear friend, Ambassador Vital, Ambassador of Israel to Mexico. I'm delighted to be here. This is a topic of Mexico and Israel. We are countries with a rich historical and cultural heritage, but also with a rich history of study of archaeology, with very important institutions in both countries and an active academic community and research community on our past on archaeological research. And this collaboration, this particular webinar, is a very new and innovative collaboration between archaeologists from Mexico and Israel, and I understand also from other places of the world, and builds upon the important bilateral cooperation that in archaeology during the last decade, in particular the Magdala Archaeological Project in Israel, led by the Anáhuac University, allowed significant research and academic exchanges between our institutions and professionals from both countries, and they are expanding in scope, meant to give further impetus to our bilateral cooperation by fully incorporating an appropriate focus on the potential and great opportunities, investments, and know-how in both our countries in the field of archaeology. And I just would like to express my appreciation to all those who have listened, especially the webinar's organizing committee, Andrea Garza from Tel Aviv University and the Universidad Anáhuac from Tel Aviv University, Gerardo Diaz from Ben Gurion University, and Rosaura Sanz from the University. And of course, to the participant specialists that will be speaking today, Mr. Lev Appelbaum from Israel, Luis Barba from Mexico, and Matthew Baker from the USA. So I wish complete success to this webinar, and looking forward to further collaboration between our institutions close to all of us. Thank you.
Muchas gracias, Embajador. Thank you so much. Now we would like to have brief words from Ambassador Vital.
Muchas gracias, Andrea. Well, you will notice in a moment that many of my remarks will overlap what my dear colleague, Mauricio Escanero just shared with you. And trust me, we didn't coordinate it. It just shows how we see things alike. So, esteemed representatives of the various universities and academic centers in Israel, Mexico, the United States, Europe, and what have you. And of course, my greetings to my colleague in Israel, Mauricio Escanero. I'm extremely happy to inaugurate this event with Mauricio, examining the international scope of applied sciences and technology in archaeology. And this for several reasons. First, this event illustrates the solid academic bonds that do exist between Israeli and Mexican universities and academic centers. The diversification of such bonds is one of the priorities of this embassy. And I expect that our efforts, together with the efforts of other stakeholders, like, for example, the many friendship associations of Israeli universities in Mexico, will bear fruit in the very near future. Secondly, and again, this is an element that was mentioned by my colleague, the theme which is at the center of this event, archaeology. Archaeology, for obvious reasons, is a discipline which is key both in Mexico and in Israel. And the cooperation between Anáhuac University and Israel's Antiquities Authority and academia, and also Spanish universities in the emblematic project of Magdala needs no introduction anymore. In this year, in which we celebrate 7 decades of diplomatic relations between both our countries and nations, what better way to do so than by emphasizing what unites us, what brings us together, which is our dedication to archaeology, through which we preserve, but bring also into the open, our deep-rooted and ancient cultural heritage. So let me wish you all the participants in this event, the best of luck. And I'm already eager to receive the link and to look at all the presentations. So thank you for inviting me. All the best.
Ambassador, thank you so much. Toda raba.
Okay, as the head of the Institute at Tel Aviv University, I want to say, first of all, that we are very proud of this event. Tel Aviv University is very happy to host this initiative, this collaboration between Mexico and Israel. I'm just coming now from a class where I taught archaeological thought and how they developed over the years. And I said in class that the purpose of archaeology is to kind of bring to light the different, the diverse, and the things that are in common and the things that are indifferent in human existence throughout time and throughout space. And this is exactly what we're doing now here. For us as Israelis, to learn about archaeological projects happening in Mexico, to share what we are doing here, to share what Mexicans are doing in Israel. It's all kind of an expression exactly of what we were hoping to achieve when we began to do archaeology. And I look at the list of the names of people who are now here listening to us, and I see Israeli names and Mexican names and American names, and I'm really proud. Thank you, Andrea, and thank you, Nitzan, for organizing this event. And I'm eager to see this event and the events that are going to follow in the next year, 2 years, who knows how many years we'll be able to continue. Thank you very much, all.
And in the name of Aviv University, I just would like to add that here at the university and at the Ancient Cultures Research Center, we are very excited to be part of this webinar, in which we will be exploring applied sciences and technology that brings together Mexico and Israel, as Samuel already mentioned. And both of us, we are two countries with rich history that continuously seek to improve their way to correctly approach the past. And that's the main topic of this webinar. And today we can understand how applied sciences are kind of an international language, just as Ambassador Vital mentioned. This language is common to different traditions and to different cultures. And when they are applied to archaeological research, we might say that this common language helps us to reach a shared curiosity on our past and our heritage. So welcome everybody. And I hope all of you to enjoy this webinar, and thank you for being here.
Okay, so now we can start. I will introduce you to Lev Eppelbaum. So Dr. Lev Eppelbaum, he's an associate professor at the Department of Geophysics at Tel Aviv University. He's the author of about 420 publications, including 10 books, more than 175 articles, and about 70 proceedings. Lev is also a reviewer in more than 40 international journals and an associate editor in the geophysical instrumentations, methods, and data systems. In 2017, he was selected as a foreign member of the Russian Academy of Natural Sciences. And due to his outstanding contributions in potential geophysical fields, in 2019, he was awarded the Christian Huygens Medal of the European Geosciences Union. At Tel Aviv University, he has taught the courses on potential geophysical fields from 1999 to 2019, applied geophysics from 2000 to 2019, and archaeological geophysics from 2010 to 2019. So now I would hand it over to Dr. Lev Eppelbaum, who will give our first presentation. Just remember that all questions you have will be answered during the discussion session. So please send them to us in the chat, and we will do our best to get as many questions as possible. Thank you.
Okay. Okay, archaeological geophysics in Israel, past, present, and future. A review. Please take into account that this is a short review, that I have no possibility to give all the necessary material. Outline of this, role of geophysical methods in archaeology, archaeology in Israel past, archaeology in Israel, geophysics in Israel present, and the future, advancement in potential geophysical fields, electromagnetic and electric methods, geophysical method transformation, and archaeogeophysics in Israel future. What is the role of geophysical methods in archaeology? You know, so the archaeological methods can provide the necessary information before the excavation, in the process of excavation, and even in the case of the excavation, we can provide some additional information about undiscovered archaeological targets. This may be used even before, maybe even instead of excavation. And geophysical investigation can protect the archaeological targets from the possible destruction. And in the end, the geophysical methods are experiments that can be repeated many times, and with a different equipment, different methodology, at different levels over the Earth surface and in the Earth surface using the electrodes. Let's begin from the archaeophysics in Israel past. You see, I think that one of the first application of ground geophysical radar was performed at the site of Sepphoris in Israel. This may be not very effective application, but this really was first. Sites of Shikmin, Northern Negev, there was applied the near-surface seismic method. El Wad Cave, Mount Carmel, here was applied the seismic refraction method. Site of Tel Afek, this is near of Tel Aviv. Here was applied the electric resistivity method. And sufficient large number of the methods was suggested to the investigation of historical and ancient earthquakes in Israel. Let's go to the present time. First of all, I'm as an expert in the potential, quasi-potential geophysical fields. I must know that was developed the unique interpretation system for interpretation of geophysical fields in a complex physical archaeological environment. Oblique polarization, rugged terrain relief, and unknown level of the normal geophysical field. For this aim, they developed a lot of special algorithms, 3D modeling, different interpretation processes. Most of the procedure were published. For instance, here you can see the generalized scheme of noise appearing in the archaeological investigation. This noise may be divided to the artificial and natural. For the removing or eliminating the most of this noise, we developed the special procedure. I cannot take time now to describe each of this methodology, but we have successive steps of interpretation even in the very difficult geological situation. Okay, I have no time to describe this system, interpretation of magnetic field in complex environments. The magnetic field application at archaeological site, this is generalized block scheme. This is a common block scheme. In the practice, this may be widened. This is most typical interpreting model utilized in the magnetic prospecting and in some other geophysical methods, for instance, in the gravity method, thermal prospecting method, electric resistivity method, self-potential method. So you can see the main geological, archaeological model that we can apply. This model of thin bed, this model of sphere or horizontal circular cylinder, this model of a horizontal plate, this model of a thick bed, and intermediate model between the horizontal plate and thick bed. For all of this method, they developed special procedure, allowing to interpret geophysical effects from this model in different geological, archaeological conditions. This is a typical model of magnetic effect from a thin bed. You can see here, we can see the characteristic point and tangents, allowing us to exactly interpret magnetic anomalies of such objects. Similar models we have from another models. You see, Shaza, what is a special peculiarity of Israel? First of all, for the magnetic method is influence of oblique magnetization. You see, it's a light example. If we will observe magnetic field over some archaeological object in the condition of inclined surface and oblique magnetization, the maximum of magnetic anomaly does not coincide with the center of disturbing body. After introducing two special corrections, first for the oblique magnetization, and second for the inclined surface of the observation, we can receive this as red point, practically exactly center of the disturbing body. This is archaeological site, Emmaus, Nicopolis, central Israel, the halfway between the Tel Aviv and Jerusalem. Here, we observed the magnetic susceptibility of the samples. After this, we observed one specific magnetic anomaly. This is a light example of magnetic anomaly. And in this place, archaeologists discovered the cave. And in this cave, they discovered the ancient lamps. Ancient lamps, you see, why the ancient lamps produce such a magnetic anomaly? The ancient lamps were composed from the fired clay. Fired clay has sufficient higher magnetic susceptibility, and accumulation of these lamps produce significantly strong magnetic anomaly. This site of Tel Kara Hadid at the south of Israel, 6 kilometers from Eilat to north. Here, we observed two strong, very strong magnetic anomaly. You see by the red. This anomaly very interpreted by using the developed methods, and very receive the position of the upper edge, and you see so very high magnetization. It was detected that the object are the ancient furnace, and here was performed 3D magnetic field modeling, and you can see here the final physical archaeological models. Two buried object of the archaeological target. This is some scheme of the magnetic anomalies interpretation in different conditions of oblique magnetization. That is the characteristical peculiarity of Israel. In Israel, the oblique magnetization is about 45 degrees to horizons. This is some typical magnetic anomaly from the model of seabed. This is another magnetic anomaly when we have the zero magnetization. So if the object having the zero magnetization occurring in the some medium, in some medium that has a magnetic character, we receive the negative magnetic anomaly, complex magnetic anomaly over such an object. This is a typical magnetic anomaly over the model of a horizontal plate. If we have sufficiently strong distance between this left and the right ends, we receive the two independent anomalies that can be interpreted by the developed methods. And here you can see the third type of anomaly. This is intermediate model. This is not model of a thin horizontal plate. This is not model of seabed. This is intermediate model. And for this model also they developed the special interpreting methods. This is a concrete case in interpretation of magnetic anomaly in the site of Ashkelon Marina. This is accumulation of the ancient garbage. You see the position of the upper edge of the ancient garbage, very detected with a higher accuracy. This is site Ein Gev, occurred in the eastern part of the Sea of Galilee. Here we very applied the magnetic method and electric resistivity method. And the magnetic curve was interpreted as a model from the seabed, and very detected all the characteristic points of this anomaly. This is ancient Roman cemetery, Banius II, placed in the foot of the Mount Hermon. You can see that we have the negative anomaly from the body of the cemeteries. This was interpreted. You see that and was received with necessary accuracy. The upper position at the edge of this body. This is site of Beit Guvrin 2, placed in the central Israel. It's a famous site. Here was detected the remains of the ancient Roman road. And it's very interesting that remains of the ancient Roman road practically repeats the position of the modern Israeli road that go from the north of Israel to the south of Israel. So this fact testifies that the topography of Israel is not changed for the 2,000 years. It was detected the position of the upper edge of the road was composed from the limestone. Limestone is not magnetic material, so we receive the negative anomaly. Okay. Can go. Very strange. I cannot go to the new slide. Oh. This is okay. This is site Nahal Tzaora 2, northern Israel. Here was detected a lot of the objects. Some of the objects were interpreted. The results of the quantitative interpretation, the results of the 3D modeling, the final model. Okay, we have no time for this. And for each of the magnetic anomaly was detected the depth, and this model is very classified as thin bed, as a horizontal circular cylinder, sphere. This work was performed together with Aviv Gopher. Okay, this is a map of the Megiddo site. You know the Megiddo site, very famous sites. This is a set of the site. This is not only site. Some examples from the site. This one anomaly 1.1 was interpreted. This very interesting model to the north of the late Bronze City Gate in the Megiddo. This model, I think this may be basaltic body with inverse magnetization. Only in this case, we receive the agreed model. What does it mean, the inverse magnetization? It's a signature that the basaltic body was created at the time when they have the negative magnetic field, or second, this may be a reverted basaltic body. Okay, this is results of 3D magnetic modeling in the Megiddo site. Also, we have here limestone wall. So we have zero or very low magnetization. We have the negative effect. Okay, this is site of Yodafat. Yodafat is the remains of the ancient Roman fortress. What I presented the sites here, we have successive steps of analysis. The first, it's observed. Second, this field was corrected for the relief influence. Here, we applied here information of parameter and received the proposition of the most disturbing body. And third, we applied a quantitative analysis of the magnetic field. What I must know is the magnetic field usually is disturbed by the influence of magnetic temporal variations, and we need to remove this effect. But we cannot apply this effect only as a disturbing effect. This effect can be used for the classification of the buried object for iron containing object and geological object. If we will observe the behavior of magnetic field variation over the object of different nature, we receive the desired solution. Gravity field. This is gravity field observation over the buried cave. Okay, this is some effect from some body is some density. This very interesting example. This model was developed on the basis of Megiddo F site. If we have here the body 3, we receive the integrated effect from the bodies 1 and 2. It's very clean series of what we have here is body. But if we will add some body of the low density, we cannot recognize this body. The entity will be very small. In this case, we can receive the necessary solution by the observation of the vertical gradient of gravity field. Not gravity field, but it's in this case we receive the necessary anomalies coinciding with the left and the right edge of this body. It's the same from some 2 caves occurring in the vicinity. In the first cave is difficult to solve that we have 2 caves. But if we calculate second derivatives of the gravity field, we receive the exact position of all these bodies. This model, physical archaeological model of the buried prehistoric cave in the Beit Shemesh, you see that if we will observe the scheme of the few parallel profiles, naturally we receive the most effective, most strong anomaly over the center, but some anomaly in the necessary will also determine the position of the body. The signature that in many cases we need to obtain the aerial observation, not single profiles, but we need to receive a map. Okay, this is a self-potential investigation in a mouse archaeological site. In the right part of this photo, this is Dr. Sonia Itkis, that received PhD thesis at Ben Gurion University. Okay, this is some self-potential maps. I have no time to describe. This is an analysis of one self-potential field and observed model. This is site of Halutza, Negev desert. Here you can see 2 anomalies of the 2 geophysical fields, magnetic and self-potential. This is magnetic self-potential field. Very interesting. So the anomalies from this field are very similar and testify the some disturbing object in the form of thin bed. The red cross shows and this is the sphere shows the position of the upper edge of this disturbing body. This site are Golan Heights. Here very observed self-potential values, and we received position of the center of some buried caves. This site of Banius 2, here very observed magnetic field. I presented this earlier, and this is self-potential field. You can see also by analysis of 2 self-potential fields, we receive the position of the buried object. About thermal field. Thermal field not frequently applied in the archaeological investigation due to the some complexity of this data analysis. Why? We have influence of the sun variation in the near surface. You can see here, so at the earth surface we have very gigantic variation, and only at the depth of 1 meter, this variation reduced to the minimum, but also have a place. This is about similarity of magnetic and temperature field. This is magnetic field. This is a temperature field. This quantitative interpretation of temperature anomalies observed in the one English site. Here we very applied two models and received some concrete values coinciding with the archaeological data. I have no time to describe this model in detail, but main conclusion from this cover that for analysis for the 3 modeling of temperature field, we can apply with some modification the methods of the 3D modeling for the magnetic field. Okay, in Israel, this methodology has been successfully applied by Mr. Chaim Paparo in the archaeological site of Crusaders Fortress Halet in Netanya. Also, what I must add, careful analysis of temperature profiles in boreholes allow to unmask a climate of the past. So, by the analysis of temperature in the boreholes up to the depth, maybe about 300 meters, no more, we can receive the temperature data from the climate of the past. But for this, we need to apply the special methodology. This is published in a few papers. For which aim we need it? We need
sorry, Lev. We need to finish your presentation to give space to the other ones.
Okay. One minute. I will finish my presentation.
Okay.
What I can say about the future? About the future of the geophysical methods in Israel. This future is associated with the remote operated vessels, both air, the surface, maybe underwater. We have the difficult kinds of this equipment that allowing us to receive all the necessary data. I think this is a future of archaeological geophysics, not only in Israel, but also in the world. Thank you for attention. I hope that I will time maybe in the future to continue my presentation. Thank you.
Thank you so much, Lev.
I have no time. Sorry that I cannot to shorten it my lecture. Okay, I will.
Thank you very much, Lev.
Thank you very much.
I'm sure we would love to continue listening to you, but now we have to open space for Dr. Luis Barba. If may I introduce him?
Yes.
Welcome, Luis.
I will
Dr. Luis. Yes.
Receive the questions to maybe to chat, maybe to my email, and I will reply to all the questions.
Thank you very much, Lev. Actually, I would like to remind everybody that at the end we will have time for questions and any question that you may have, and we will have discussions also. But again, if you would like to share your contact information at the end, it will be perfect. Thank you very much. And if may I, Dr. Luis Barba Pingaron is a chemical engineer, master in geology and doctor in anthropology. He's the coordinator of Archaeological Prospection Laboratory at the Institute of Anthropological Research at the National University of Mexico, UNAM. He specializes in archaeometry. He is a member of the Network of Applied Sciences for the Research and Conservation of Cultural Heritage under the National Council of Science and Technology, CONACYT. He's also a member of National System of Researchers, Sistema Nacional de Investigadores, since 1984. And he's also a member of the Mexican Academy of Sciences. And of course, I would like to add that he's in charge of the archaeological prospection analysis carried out at Magdala, Israel in 2010 and 2011. So he's the perfect example of collaboration between both countries. Welcome, Luis, and please, we would love to hear you.
Thank you. It is a great pleasure to be with you. Thank you for inviting me to be part of this webinar. In fact, this is my first experience in webinars. I've been talking about all these topics in many places, but this is my first time in a webinar. Let's see how it works. Okay, I am just one of the members of the Archaeological Prospection Laboratory in the Institute of Anthropological Research in Mexico from the National University of Mexico. And my colleagues, Jorge Blancas and Agustin Ortiz, are part of this team. Let me tell you our experience in applying a methodology that we developed in our laboratory some years ago. I will begin showing this model, and this model proposed by Chen Hall in 1975 gives us an idea of the very limited information we can get from the surface of a site compared with the original amount of information present during the operation of the ancient settlement. In addition, when we want to interpret the characteristics of a structure of an archaeological site through the information provided by any isolated technique, we realize the minimum information that we can recover from them. In 1984, in my PhD thesis research, I tried to put together a series of prospection techniques to increase the quality and quantity of information that could be recovered. By that time, we studied some archaeological sites and demonstrated that it was possible to recover and integrate a diversity of information from the surface, even when it took some extra time. Some years later, the methodology was modified because the arrival of a new generation of geophysical equipment, especially the georadar, allowed to determine the depth of the studied features. In addition, the availability of more satellite images with much better spectral and spatial resolution provided the first approach to our sites. At the end of the procedure, we began to experiment with the chemical analysis of soil samples in field with the use of the portable X-ray fluorescence. As a comparison, medical imaging before any surgical intervention is now a common practice in modern medicine. But it was not always like this. The acceptance of these techniques took many years and many legal demands. In archaeology, has taken some more time, and depending on the country, the archaeological prospection techniques could be more or less developed. England has a long tradition, and they have very well-established procedures and legal regulations, but this is not the case in many other countries. In 1990, Anthony Clark published his book, Seeing Beneath the Soil, and published this famous illustration. That is a very simple way to show the main characteristics of the context and the way each prospection technique provides information. Also shows that techniques are complementary and can discriminate the information to support better interpretations. In addition, displays the way chemical techniques do not overlap the geophysical data, but provide another kind of information more related with the chemical enrichment produced by everyday human activities. In 1985, by the first time, this aerial photo showed the clear spots in the soil of Stoyohualco, Teotihuacan. Doing chemical tests, we realized that clear spots were closely related with high values of carbonates and hypothesized that this could be the consequence of the use of lime in architectonic plasters. Then we continued working in different parts of the Teotihuacan archaeological site, and through the years, we recognized these clear spots in many other open areas. 2 kilometers to the south of the citadel, following the Street of the Dead, we arrived to the Tlahinga area of the Teotihuacan city. This is the Tlahinga area. This part was separated of the core of the city by the San Lorenzo River. This has been considered as a low status neighborhood, and this area is presently going under a rapid urbanization process, and part of the goals of the Tlahinga Archaeological project, directed by David Carballo, has been to recover information before it could be lost under the modern urbanization. This long-term collaboration project between the Boston University and the National University of Mexico has recovered information from close to 1 square kilometer and provided new insights in the knowledge of this area. In this case, we applied the updated archaeological prospection methodology as a part of the project of a PhD student. From an aerial infrared image provided by Deborah Nichols, we realized that there are sharp differences in soil behavior in this spectral band. In the more elevated areas to the south, we observe darker colors. While getting closer to the San Lorenzo River, the color is lighter. In the cut of the river, we observe the presence of volcanic tuff with layers of caliche that could be responsible of the observed color changes. In addition, we found a close correlation between some soil clear spots and the structures proposed by Milon in his publication in 1973. This is one of the clear examples of this correlation. In this way, we recall an interesting relationship between the clear spot detected in 1985 in Ostoyo Huelco and the clear spots observed in the aerial images from Tlahinga in 2018. After this first approach with aerial images, we proceed to the topographic survey to acquire elevation data with an Aztec differential GPS. In general terms, to the south is the Patlachico range, and the slope goes down towards the course of the San Lorenzo River in the northern edge. There are some outstanding features in this map. It is evident the depression about 40 meters wide that marks the continuation of the Street of the Dead. In this part, it was excavated in the volcanic tuff. It can be seen the maximum elevation of the main structures besides the railroad track identified as the neighborhood center. In the surveyed area, we can observe interesting inflections in the contour of the lines. In some of them, we place the grids for the magnetic study in this area. To get a more updated and detailed information of the surface of the whole studied area, we used phantom drones to acquire aerial digital images to build an orthophoto mosaic. In this way, we obtain an image that displays many clear spots, but besides this, we got a digital elevation model of the terrain that revealed small elevation mounds. In the PhD project of Jorge Blancas, he experimented with various combinations of the spectral bands of the satellite images, some with better success than others. But in this case, we can observe that the magnetic gradient map shows some structures that do not overlap the original size and shape of Millon's map. The Millon's map interpretations are the white rectangles or squares. At least in this area, the shape of the apartment compounds is not rectangular, and the final form seems to be consequence of additions in the perimeter of the original structures. This is an example of the detailed study of the Mount 34. We made the magnetic gradient study and interpret some of the linear features in map marked here in orange. Then we did 2 verification grids with GeoScan RM15 and that are represented in this blue and yellow table color. Finally, in the same grids, we performed a georadar study that verified the information provided by the previous techniques and informed about the depth of the buried structures. In addition to this information, we knew that in the infrared image, it was a clear spot that identified the use of lime plasters to finish the architectural surface of this unit. In the southernmost part of the Street of the Dead and close to the railroad, there is another elevated area that was studied with magnetic gradient, but did not show well-defined patterns. Nevertheless, there was a rectangular area that concentrated a large amount of obsidian microflakes. This area was excavated to verify both indicators. During excavation, appeared small rooms built with a mixture of mud and stone, but no lime plaster to finish the surfaces. This was consistent with the absence of a clear spot in the area visible in the area visible in aerial images. After the contrast found in 2 of the studied areas, we inferred that could be differences in the access to building materials and socioeconomic level between the 2 apartment compounds studied. Then we changed to the Galilee area. Here we also had the opportunity of applying our methodological proposal in Magdala, Israel. It was in 2010 that Marcela Zapata, director of the Magdala Archaeological project, invited us to participate and study around 3,000 square meters in the western shore of the Lake of Galilee. The project was detonated by the construction of pilgrimage center and the discovery of a synagogue from the 1st century that supported the idea that the Magdala town could be around. Under these circumstances, the Anáhuac University and the National Autonomous University of Mexico signed a collaboration agreement to work together in the site. As usual in this kind of projects, the first approach was the use of an aerial image to register the conditions of the surface. And in this case, most of the site was covered by grass, except for the area closer to the lake. Then we proceed to register the topographic relief with an Aztec differential GPS, and after processing a residual map, we observe that we have at least 3 terraces in the studied area. This is one of the terraces, the other one is in this part, and the last one is in this other portion. The magnetic gradient study revealed a very noisy map showing a great dispersion of stone fragments under the grass layer. Nevertheless, we managed to recognize some linear patterns that suggested the limits of buried structures and perhaps some channels. This study covered 20,000 square meters and most of the available open areas in the terrain. Results at this point showed that in all probability, we were on top of a town related with the synagogue that was built using basaltic stones that, when collapsed and dispersed in the area, made quite difficult to interpret the form and size of the structures with the magnetic technique. Then the next step in the procedure was to apply the electric resistivity equipment. After the systematic survey of the area, we began to realize that this technique provides a clear image of the walls of the buried structures and allowed to define the shape and size of them. This is because the electric field was not affected by the dispersed stones on surface. It is exceptional how sharply detect the standing parts of the walls made with the same stone. That walls prevent the conduction of the electric current into the ground and produce high values of electric resistivity. In the western part of the studied area, it is possible to observe many small rooms made with basaltic stones. Among these rooms, excavation identified several ritual baths. In the central part of the land, we can see that the structures are bigger and seems to be public buildings in open spaces, while in the eastern area, we recognize again small rooms made of stone. The integrated interpretations of all available data provided a rather complete map of the various structures that formed this town in the 1st century, possibly called Magdala. In this case, most of the important information was provided by the electric resistivity technique. In this instance, the information from magnetic gradient was noisy and difficult to understand, and georadar was limited to verify some of the anomalies and to provide information concerning to depth. Final remarks. In Tlaquinga, Teotihuacan, the integrated studies provide information about the distribution of the structures in the southern part of the Teotihuacan city, the size and shape of the structures, the kind of building materials used, and suggest differences in socioeconomical status of inhabitants of this part of the city respect to the rest of that. Magdala was a very interesting experience and challenging to test our methodology proposal. It was also very challenging to make a topographic map 200 meters below the sea level and work in the summer close to 45 degrees centigrade. After 4 years working with this methodology, we realized that it is not always possible to apply all techniques because the time and cost frame of the archaeological projects. But when it is possible, the amount and quality of the information recovered is incomparable. Thank you very much.
Thank you, Luis, for this very interesting lecture. I'm glad to present our next speaker, Dr. Matthew J. Adams. Matthew is the director of the Jezreel Valley Regional Project, director of the Center for the Mediterranean World, and co-director of the Tel Megiddo expedition. He has excavated in many sites in Egypt and Israel, and recently completed his 8-year term as the director of the Albright Institute of Archaeological Research. His research deals with a wide range of topics, including Egyptian connections in the Southern Levant, implementation of scientific methods in the study of archaeological finds, and combining digital archaeology in the regional study of the Jezreel Valley, which we will hear of in today's lecture, titled Multi-Tech Approaches to Remote Sensing at Legio Lejeune, Israel.
Great, thank you. Thank you very much for having me. Thanks for the nice introduction. Hope you all can hear me. There's a big construction project happening just outside, so you might hear some strange things. during the talk. Let's get my screen up here. Okay, can everybody see that? Good. So I'm here as one member of a group of people who have contributed to all of the things that I'm talking about here, including Eileen Ernenwein, Ben Lagemeyer, Ido Schicht, and Yotam Tepper. I am just the archaeologist, so some of the technical things that I'll be talking about, I'm half making up, and I won't be able to answer too many questions on those, but I can try to trick you as we go. Here we are in northern Israel, around the site of Megiddo, which is of course in the Jezreel Valley, at this location. Many of you are familiar, of course, with Tel Megiddo, but we are dealing with a concept that we call Greater Megiddo or Greater Legio, which includes a very large area, some 9 or more square kilometers, that has an archaeological complex ranging from the Neolithic all the way up to modern times, with pretty much every period represented along the way. You can see the chronology there on the left side of the slide. Numerous toponyms from historical sources are associated with this archaeological complex, including Megiddo, Legio, the Roman legionary base, Kfar Odnai, the rabbinic era Samaritan village, Lejun in Arabic, Crusaders, and of course modern Kibbutz Megiddo. This area has been explored archaeologically, but most of that archaeology is really focused on Tel Megiddo itself, which is really a very small portion of this large area. The excavation history is there on your left as well, including the famous excavations by the University of Chicago in the 20s and 30s. Our own excavations since the 1990s also focused at Tel Megiddo. Surveys and excavations by the Israel Antiquities Authority throughout the area based on construction projects, road projects, and so forth. Beginning in 2010, we created the Jezreel Valley Regional Project as an offshoot of the Megiddo project to really explore the greater Jezreel Valley, focusing first and foremost on greater Megiddo. We've done this through excavations at Tel Megiddo East, at Lejun, which is under Kibbutz Megiddo, Legio, and more recently the cemetery associated with the Roman legionary base. We've also conducted a number of surveys around this area as well. And now on the focus of this talk today, some of the remote sensing that we've done. And as we go through this, I'll kind of speak historically about our use of remote sensing at the site and some of our first attempts, and take you up through some of the things that we're doing now. And of course, many thanks to all of our volunteers and teammates over the years. One of the main questions that occupied the project early on in the 2010 and 11 was the location of the legionary base. We knew from historical sources that it was somewhere around Tel Megiddo, and there were a variety of reasons that we thought that are not relevant at the moment. Yotam Tepper and his PhD advisor had originally suggested that the location of the base might be this hill to the south of Tel Megiddo, which is labeled here as El Manach. And his surveys had suggested that this might be the case based on finds of Roman pottery in the area and a number of other things as well. So we wanted to try to test this idea, of course, through excavation, but first and foremost through remote sensing. Here you see some examples of Roman legionary bases, what we were sort of expecting to find. Is that disturbing? Can you hear there's a dump truck or something just outside? Oh, try to ignore it. In any case, this is sort of what we were looking for, and it should be pretty obvious. What was interesting is that these kind of bases are well known throughout the Western Roman Empire, but none of them had been located, at least of this type, in the Eastern Empire at all. So we weren't exactly sure that this was indeed what we would be able to find. One of the first things that we did was acquire archival LiDAR data. It's a 12-centimeter resolution of the entire Jezreel Valley. And this was meant to inform much of the work that we would plan to do going forward. But we also were able to, of course, use it at Legio. Here you see the field of El Menach as it is roughly 10 years ago. You might already from this aerial imagery be able to make out some large rectangular feature. This was our first real high resolution view of this, the LiDAR data, which came with aerial imagery as well. We were able to enhance the LiDAR data in a variety of ways and create this slope model, which also really highlighted the rectangular structure beneath the surface and other somewhat linear features as well. Once we had this data, we brought in a team to do some ground penetrating radar and electromagnetic studies of one small portion of this area, covering one of the large rectilinear features that we saw at the site. Here you see the results of that here on the bottom right. I have no idea what it is, but probably Lev can interpret that for us. But what we were able to do is match some of the anomalies that we saw here with some of the topographical features that we saw in the aerial imagery, and from that go out and do a 2-week excavation at the site, crossing over some of these anomalies. Here we're now looking to the south at the field, and our excavations carried out crossing one of these long linear features that we saw in the aerial photography, crossing some of the magnetic anomalies and up onto the higher part of the plateau. This was really one of the easiest excavations I have ever done. Within the first day, we found architectural remains, including what we now understand to be the main wall of the legionary base, pipes, water pipes, sewers, lots of roof tiles and other artifacts that are clearly 2nd, 3rd century, exactly the time that we know that the Roman legion was located there, and some other pretty finds that came out within the first day of excavation. Over the next several years, we opened up other excavation areas, primarily focused in what areas B and C at the center of the camp, which I will just tell you in advance, we now understand to be 2 sides of a large compound that is the headquarters of the Roman legionary base. Here it is with our reconstruction of the base on top. That is the Principia. That is the headquarters building. Area B excavating in the the back portion of the compound, and Area C in the front portion of the compound. I'll just run through a couple of images now to give you a sense of that Principia excavation, then I'll continue with some of the remote sensing. Our reconstruction of the base. This is now 5 years old. We need to do a new one, which we'll do in the coming years. The Principia building itself. This is what a Principia looks like based on other examples, and ours in fact looks very similar. It's a large compound, roughly, I got the exact measurements here, 72 by 90 meters. You can see that it consists of a large open courtyard surrounded by columns, and the rear rooms served a variety of purposes, including housing the standards of the Legion and the treasury of the Legion and so forth. So lots of fun and interesting things there. Here I'm showing you some ortho photos of our excavation in these 2 different areas, along with our reconstruction. And on your right, an example of a similar structure from Lambesis in Algeria, which is more or less the same layout as ours. Just some other examples of what the architecture looks like. Main gate in the front of the building. The rear chambers at the very center. This is the room which houses the standards of the Legion. You'll see that it has a special jutting out piece of architecture that goes behind the building, into which a semicircular apse was constructed with an altar at the center. Other parts of the back include a series of rooms. There is some aerial imagery to give you an idea. Keep some of this in your mind as you see some of the remote sensing coming up. The dump truck is going to dump something on me. Okay, so phase 2 of our remote sensing project included ground penetrating radar electromagnetic induction and magnetometry, now with Eileen Ernenwein from East Tennessee University. The idea is that we would cover the entire hill with these three technologies. And in the first season, Eileen was able to test some of this and more or less figure out which of the methods would be most applicable to the geology of the field in question, as we'll see in just a moment. At the same time, we also carried out seasonal aerial photography, creating orthophotos of the entire site on a more or less regular basis as crops were growing in the field. Yeah, let's go here. These are some of the results of the three techniques that Eileen has used: magnetometry, EMI, and GPR. As you can see from the left, GPR was the most successful, and she got her best results in the colored image here on the bottom right, combining the electromagnetic data with the GPR data in a variety of different software packages that were later then combined. Next, we applied this to a large swath of the camp itself. These are the results. I'm actually going to skip ahead to this slide, which is a more recent coverage of the GPR data. This is GPR combined with the EMI, and you can really see the high resolution of data that we're getting out of this, such that we can map individual buildings with high precision here. Some images from the Principia, which is the excavation area that you saw previously, with our material excavated over top. And here you see the GPR and EMI combined with our excavation areas. You can make out very clearly the main road, which has a sewer running beneath it, a lot of the walls of the building, and so forth. Can you actually hear me? Yes? Okay. Sorry for the extra noise. Good. With regard to the aerial crop mark survey, this was a lot of fun to do. It usually meant flying different types of drones over almost 10 years. We started out at the early part of the project. They didn't have the commercially available drones that we have now. So we built a couple of drones and crashed a few drones along the way. We ended up using a DJI Inspire, graduating to a Mavic Pro, Mavic 2, Mavic 3, and now we're using the Mavic 3 Enterprise Multispectral, which just came out, and the data is really fascinating. I'm sorry, I don't have any images from that to show you today, but this drone has thermal sensors, multispectral sensors, as well as the regular RGB high resolution. And that is kind of a game changer for being able to deploy these technologies quick and easily, especially when you're trying to take images every couple of weeks across an entire year. Very easily and deployable. We developed some pretty simple workflows using Metashape for orthophoto creation, Adobe Photoshop with Geographic Imager for various enhancements, and Adobe Illustrator with Map Publisher for digitization. This is a fun image, and it gives you a good sense of what these crop marks can give us. This field was, in this particular season, was planted with alfalfa, and it was flowering at a very particular moment in time. Well, it lasted really only a week, and we were very lucky to get this imagery here. You can see there's like a purple shade. That's the flowering that is only happening in specific locations. Let's take you to this image here. Here we're looking at the Principia. The drawing on the right is showing you our excavations, and you can make out in purple and lack of purple elements of the street. Here you can see other images across the entire, this is actually the southern wall of the compound. I'm sorry, of the entire legionary base and other elements here. This is somewhat unique, and we weren't, unfortunately, not able to get an ortho photo this day, just some opportunistic images. But some of the other images we were able to acquire over other seasons and years did prove incredibly valuable for reconstructing the overall layout of the base. Just a few examples from different seasons to give you an idea. Our most successful image comes from April 5th, 2017. Here we have a wheat crop that is just captured at just the right moment to see a wide variety of features. I think that next slide zooms in on this area here, where you can see streets, walls, and so forth. I don't have the most recent digitization, but we are able through these different technologies to trace and map, excuse me, a lot of the walls and other features that we've seen, and now have produced a pretty detailed map of the entire base that helps us guide our excavations. Our most recent remote sensing phase, call it phase 3, was bringing in some more professional folks. Some of you may know these guys, Ben and Ido, who've started a new company called ENSO that specializes in remote sensing and geophysics, especially, but not only limited to archaeology. I encourage you as archaeologists working in Israel to check out their website. They offer a variety of services, some of which you'll see here. With their help, we now have high resolution LiDAR coverage from drone-mounted LiDAR sensors of the entire area, not just of the hill of Leggio, but all of Greater Megiddo. We have ortho photos from a variety of seasons of all of Greater Megiddo, multispectral thermal imagery from Greater Megiddo as well. I'll show you some examples from Leggio. This is some of the equipment that they were using as of 3 or 4 years ago, included handheld LiDAR sensors, drone-mounted LiDAR sensors, and multispectral sensors as well, both of which used together could get all the nooks and crannies in a large landscape like this that has rivers, it's forested, and includes open fields as well. This is an example of what they were doing with the hillshade models and the LiDAR at nearby Tel Abu Shusha, and some of the different processing techniques that help to bring out microtopography on the site. Here is an example of the multispectral imagery enhanced with NDVI processing of Leggio itself, which brought out a number of features that we never saw even on the aerial photography or the GPR. Here, and here you can see a few examples of the same area with the multispectral and RGB sensors and some of the enhancements that we're able to pick up architectural features subsurface. The thermal imagery is a little bit lower resolution, but itself was able to give different kinds of data and different results from different areas in the field as well, and also contributed to our overall map of the site. As I said, we are now deploying all of these technologies across Greater Megiddo. We have, this is mostly just for fun, a British base from the Mandate period, which is established near Leggio, though they didn't know it was a Roman base prior to that. We've been using LiDAR and multispectral and thermal imagery here as well to record some of the cultural heritage features of the site itself and map these modern buildings that are now sitting inside of a forest. Great. Just some other images here of Greater Megiddo and some of the remote sensing that we're able to do. Okay. So ultimately, we are currently in the process. We have collected all of this data. We continue to collect additional data from different times of the season, especially with the thermal imagery and the crop mark imagery. Different times of day and different times of year produce different results. So we're in the process of integrating all of that and deriving archaeological interpretations from those. I want to end with this other feature here. This is less about archaeology than it is about presentation. During our excavations, we create 3D models using photogrammetry of every single context. That is, every locus gets its own 3D model, And these are, of course, very helpful for a variety of reasons, not the least of which is taking those 3D models and putting them into an augmented reality software package such as this one here, and putting those 3D models back on the site in exactly the location in which they were excavated. So here you're going to see one of our first tests of this software. You are viewing through an iPhone as we turn on and off one of the 3D models in a field 8 years after it was excavated. So here we go. It starts off a little bit slow as we look around and get a sense of what the field is like. On your left, you're seeing the 3D model being turned on. So it's on 30% now. We're in the middle of a wheat field. And you see just in front of you now the beginnings of one of our 3D models being placed. Turn around. There we go. Right, there it is. So this is a square which was excavated some years before. We're standing in this field now. And we're now experimenting with ways of using this not only for public presentation, but integrating it with our field recording methodology so that if you're excavating a square near an excavation unit from previous years, you can literally turn on the previous excavation as needed and show individual loci, walls, and so forth. And this, of course, is visualization and it's for fun. But of course, the human mind is the great processing unit that we use every day, and visualization really helps that thinking process in the field. So thanks for listening. That's just a sample of some of the fun stuff that we're doing at the JVRP.
Wow, thank you so much, Matthew. Super interesting. Very, very interesting, the 3 lectures. Gerardo?
Yeah, thank you everyone. Thank you, Lev, Luis, and Matthew. It was really, really interesting, and I think it provided a lot of information that maybe most of us really didn't know about it, or really didn't have the perception that you can all apply all these methodologies and see too much on the ground. So now it's time for the discussion session, and we have one question from Juan Maria Solana. She asked, she would like to know if there is a technology to identify caves. So does anyone can reply? Yeah, I repeat the question. So she is asking if there is a technology to identify caves.
Yes, like caves, I think that this question would be more what Juan means is hidden caves, caves that were covered by a landslide or were covered, like completely covered, and we cannot see them, but we know that these are beneath the compact soil. Is there a way to find them? If that is so, which type of geophysics method would be correct to use?
Okay, can I say a few words about caves? Yeah, so for detecting underground caves, practically can be applied all geophysical methods. First of all, microgravity, magnetic, electric resistivity, self-potential method, and of course ground penetration radar. But it strongly depends about the surrounding medium. For instance, from our experience for detection caves, sinkholes in the Dead Sea region, ground penetration radar practically does not work due to the presence of the salt, due to the low resistivity of the surrounding medium. At the same time, here we applied the microgravity method. As follows from my presentation, we detected the underground caves using the microgravity, using the self-potential method, and using magnetic method. We have several cases or successful case of application of this method, but strongly depends in the for the concrete geological archaeological situation, the physical properties of the surrounding method.
Thank you. We have another question for Luis Barba. So for you mentioned about your methodology, where can we read about it or, get more in touch about this methodology?
Excuse me, could you repeat, please?
Yes. You mentioned that you have a already established methodology. If
Yes.
there are people interested in this methodology, where can they read about it?
Okay. There are a couple of publications some years ago, and if anybody is interested in that, I can share these publications. The main idea is just put together several techniques, beginning with the ones that cover more extension in the field, and finishing with the ones that demand a lot more of time in analyzing samples in the laboratory. And it is sometimes very rich, the final information that you can get. That's all.
And this question is for Matthew. So from your experience, which combination of methods have provided the best results?
I think just as Lev had said, it really depends on the particular site, the geology of the area that you're working in. In our case, the aerial photography, crop marks, and the GPR, were really phenomenal. You saw some of the images there. We can map out the entire base. But one advantage we have is that we have a single period site at that particular location as well. So there's a lot of luck. The same techniques used at Tel Megiddo are completely useless. So it really depends on the context that you're dealing with.
Thank you. And there is another question for basically for everyone. So do you think that applied geophysics or similar course should be included in the BA program for people pursuing the degree in archaeology?
Yes, I think so. It is something necessary in the curricula of the undergraduate students. Perhaps not in the level of doing by themselves, applying these techniques in the field, but yes, they need to know all the potential of these techniques in his future career.
Okay, thank you. I think maybe we have more questions. Does anyone want to ask maybe directly?
Yes, can I ask a question?
Yeah, for sure.
Right. I actually have two, but let's do it one at a time. Lev, in your lecture, you mentioned the magnetic anomaly of different kinds of finds. You showed the lamps, for example, and the kilns and so on. And you said that it can be used as a kind of almost a substitute for excavating, right? And I was wondering, and maybe this is a question open for anyone who has feedback, how precise can we identify these different finds without excavating? How precisely? How accurate is the information that we can get to identify different finds? Are we there yet, or is it not that advanced?
Thank you for a good question. You know, the methodology developed by I and my co-author is specially intended for the complex geological, archaeological condition. This method works, and when we have a combination of different anomalies. And what I can note, I have one case from the Bey Guvrin 2, where it detected the remains of the ancient Roman road. I have received this data, and the excavator asked me to perform the interpretation very quickly, so they need to have during the half of day. I performed the quantitative analysis and 3D modeling, and since that depth of the APH here is 2 meter 56 centimeters. After the excavation, they informed me, so not 2 meter 2 meter 56 centimeter, 2 meter 60 centimeters. So that mistake is 4 centimeters. Really, this was a very good result. The mistake was about 1.5%, maybe less. But usually I receive the results about 5-10%. 5-10%. It's a usual accuracy.
Thank you. And Geraldo, can I ask my second question as well?
Yeah, yes, sure. Go ahead.
So this is for everyone, and from asking from again from an archaeologist perspective. So you showed different, let's say, different resolutions of using these different methods. Some of the projects are very large scale, mapping complete sites or complete structures and so on, like in the Megiddo area. And in some places you looked at very small finds. And I wonder, as an archaeologist in the field, how easy is it, or how flexible are you with during the project changing the method and going from, you know, the big scale to now looking at one, let's say one floor, one item and so on? Can you do this switch, or is it not, or is it more, you know, matters of budget and so on are keeping us more rigid in utilizing all of these different methods?
I'll chime in. Again, I think it depends on the method you're talking about. With the GPR, for example, I mean, this is something that we have to have the specialist for. We have to bring in the equipment. It also has its limits in terms of resolution as well. And in our case, we are using the radar by dragging it across the landscape. So that's very time consuming. In terms of photogrammetry, which is less of a remote sensing technique, although it does have that potential for topography and so forth, that's something that we've now deployed at a variety of scales, from huge landscapes all the way down to tiny artifacts such as seeds through a microscope, and everything in between. So that's something that really scales very well.
We have another question for everyone. This is from Sandra Garza. And the question is, according to your experience, which is the best methodology or technique that you have worked upon, and where was it applied and why?
Well, in this case, I could say that there is no one of the techniques is the best, because it depends on the goal of the project. It depends on the geological conditions. It depends on the size of the archaeological site you are studying, or the archaeological structure you are working on. And all these details has to be taken into consideration to define which is the best for any case. From my perspective, it is common that applying 1, 2, or perhaps 3 of the archaeological prospection techniques, not just to have the 3 times the same information, but because you can make difference between the information provided by each one of them, and also to confirm your interpretation, it is quite useful to have at least 2 of the techniques. In fact, no one is the best, and you should take into consideration so many variables.
Any other question? There is another here. It says, for example, let's say that you use GPR and there is a complex terrain and let's say like slopes or scatter rocks. How do you deal with this issue, for example? This is for everyone who would like to answer.
I am not the GPR expert, but our expert, Eileen, uses the LiDAR data that we have and the microtopography to correct for all of the GPR data on the slopes so that everything can be put back into its proper place geographically. And that works very well. And we've been able to tease out structures that we couldn't see with the raw data from the corrected data. So having topographical information is very useful, and the software packages these days can handle that.
Anybody has another question? Okay. I think that's all the questions from the audience. So
Well, there is one last question
about
asking.
When is the next webinar? Yes.
Yes.
So we intend to do it. Yeah. So we intend to do it around September, November, the kind of winter season. So this will be the next webinar.
Yes. So if there is no other question, we are very thankful about having you all here. We are very thankful for these very interesting presentations. And actually, I have homework to do now, just to think about different sites that I am looking how to approach them when I do not have, or we do not have the budget to, or the time to excavate them. How can we have like the first approach with geophysics?
And what do you
As
think?
Gerardo said, by the end of this year, if you want to receive information from us, you can sign into our mailing list that I am just adding here. We can send you the link, well, the YouTube link of our Tel Aviv University YouTube channel, in which this the recording of this webinar will be presented. And so far, this is it. Thank you so much for the organizing committee, and Itzan, Gerardo, Rosaura. Thank you so much for Tel Aviv University and Anáhuac University for being our host.
Yeah, thank you also to Lev, Luis, and Matthew for your time and your sharing your experience. It was really, really, really great for us and provide a lot of knowledge.
And thanks to you all, and also the ambassadors, Mauricio Scanero and Svital, for being here with us and wishing us the best luck for this project.
Congratulations.
Thank you so much, Ambassador Mauricio. Thank you very much.
Congratulations. All the best.
Well,
Thank you.
I would like to thank for your enthusiasm and for your hard work to put together all this information, all these persons, and I wish you the best for the future webinars. Thank you.
Thank you, Luis. Thank you so much.
I think Lev have another question.
My last question. First of all, thanks to all participants. One question, maybe we can think about the publication of our seminar, of lectures, maybe short abstract or maybe proceedings of this seminar.
Yeah, for sure. This webinar will be recorded and it will be sent to those who register. It will be also on the YouTube channel, as well as the summary of your presentations, the abstract of your presentation.
Thank you.
Yeah, thank you. So hopefully we have more projects between Mexico and Israel, and we keep, shortening the gaps between humanities and applied sciences. Thank you so much.
Yes.
Great. Goodbye.
Yeah,
Ciao.
goodbye.
Thank you, everyone.
Thank you.
Goodbye.